All right, I think we'll get started. Thanks everyone for coming. How was data night out? Love it, love it. And I'm so glad this session is not happening at 8 in the morning, right? As normally does happen at TC sometimes. So again, thanks all for coming, and welcome to Advancing Your Big Data Strategy. My name is Vaidi, and I'm part of the product management team here at Tableau. So my role is to work very closely with our technology partners, so AWS, Microsoft, Google, Cloudera, and several of the big data platforms Tableau integrates with, and build joint solutions for customers. I've been here about 4 years, and prior to coming here, I was an analytics practitioner, like so many of you, for many years. In a Tableau conference 2012, that was my first Tableau conference, which I attended as a customer. So I was sitting in the audience, and it's been an awesome journey. And with me, I have Robin. That joke always works. Yeah. So again, very excited about this session. And this session has evolved over the last few years. So I remember we first delivered the session, I think 3 years back, and back then we called it, "Do you have a big data strategy?" And then it became, "What is your big data strategy?" And today we're calling it "Advancing Your Big Data Strategy." Essentially, the title itself is a reflection of how quickly this landscape has changed. The audience has matured. There's newer technologies, and we're also learning how to grapple with all these different transformations. So, really excited again. And and by the way, did you see they made a banner for it as well? So, and I didn't know that until I got here. So just before I start, I want to put out a few feeler questions just to, gauge the pulse of the audience. So first is, how many of you have a data platform and a data strategy? Okay, and and when I say how many of you have, it has to be documented, it has to be vetted. So you have a data platform and data strategy. Cool, and not a lot of hands went up. That's interesting. Is your data platform or strategy set up for analytics? Okay, great. How many here, and this is a two-part question, how many here are part of the data platform team? And how many here are part of the team that is administering and deploying and provisioning Tableau to the rest of your organizations? So first question, how many of you are part of the data platform team? And how many of you are provisioning Tableau to the rest of the enterprise? Interesting. So I see a little bit of an overlap. It is not always the case, so that's great. And how many of you are considering or are already in the cloud? Tad from Expedia over there, but that's encouraging as well. So it's it's interesting. I saw roughly 30% of hands go up. So it's a very representative sample. About 30% of our customers are in the cloud as well, right? So we obviously love to hear feedback. So at the end of the session, strong reminder to go into the app and tell us how we did. So here are some of the things we'll cover today. So here's the agenda. First, we're going to talk about the major transformations that are driving this modern data landscape. Then we'll reintroduce big data. Big data, the way it was defined a few years back. Sorry. Okay, perfect. So we'll reintroduce big data as a term. And we'll see how that definition has evolved and what's the best way to define it today. We'll then review the principles of a modern data architecture. and we will look at how those principles have been applied by some of our biggest and best of breed customers who've deployed Tableau on big data. Then Robin will demonstrate how some of those principles can be applied to a real use case. And we believe that demonstration is very representative of a lot of things we see in the enterprise today. So I think that's going to be pretty exciting. And finally, we'll just close out by recapping some takeaways. I also want to talk about some of the things we're not going to be covering today. Just to level set expectations, we're not going to deep dive into how to make Tableau performant on big data. There's a lot of other sessions, one particular by Jason Oakes, and I don't know if there's a repeat session, but strongly encourage you to check out the recording. So designing efficient workbooks, that is not out of scope. We're not going to go into how to avoid unnecessary joins, how to optimize extracts, when to create an extract, when not to create an extract. All of these things are very, very important, but we chose to focus on architecture patterns, right? That is the focus of the session today, right? What are some commonalities that the best enterprises do in terms of designing their big data architecture? And what can you learn from that? That is the focus of our session. We're not going to go deeper into some of the specifics, like database tuning and partitioning, all of which could potentially be part of another session, but not today. Right? And the goal of all goals is to develop a platform mindset. If everyone goes back home with the single takeaway of considering big data as a platform of different components, all of which do different things and not a monolith, I think that would be what we would hope to achieve. Right? So with that, let's talk about the three major transformations that are happening today. Right? First is a lot of customers are moving to the cloud for a range of reasons. Their data center leases are expiring. There's a facility/real estate decision, or they have been asked to respond to a digital transformation mandate. So there's a range of reasons why customers are moving to the cloud. They're also simultaneously re-architecting their data platforms to optimize for analytics. And usually these are converging waves, because doing both things at the same time, it's not easy. It's usually a very violent transition. And there's a reason why not every hand went up when I asked, is your data strategy optimized for analytics, right? But when you add the fact that how critical analytics has become, this almost takes on tsunami-like proportions. And making it harder is the fact that a lot of externalities and changes are coming at you faster than you have the time to react. So a great example is when GDPR happened. It happened so fast. You had these new needs for regulation and compliance and oversight of data compete with the needs to unleash data across the organization for self-service analytics. And that conflict, people felt really, they found it really challenging to reconcile those two competing needs. And that affected your data strategy, your platform strategy, and your cloud strategy. So with that in mind, let's attempt to define big data, right? So let's look at how big data has traditionally been defined. So on the left-hand side is the traditional Gartner definition, which is data that is large volumes, diverse formats, high velocities. That is what big data was traditionally defined. But in the last couple of years, as needs have evolved, as architectures have evolved, we've increasingly seen big data being defined as any data that swamps traditional approaches of dealing with it, where you're required to innovate in some way in how you curate it, store it, process it, analyze it, right? So if you think about it, these additional needs of curation, storage, process, and analysis imposed by big data, they are applicable to any data. So all the best practices, all the things you're doing to your architecture to accommodate big data are some of the same things you should be doing to accommodate all data. So big data in that, if you look at it through the lens of analytics, big data is just data today. And we believe that it's not just the 3 V's of data that are driving architecture and strategy. Well, they definitely do, but it's not the only thing. It is the 3 V's of analytics, right? The 3 V's of the needs of analysis. The needs of analysis, we believe, are growing at the same rate as the data itself is. So what do we mean by the needs of analysis? What do we mean by the 3 V's of analytics? Well, we're looking at the volume of use cases, right? So every org today has to accommodate, as part of its data strategy, different ways of analyzing and processing data depending on the use cases they're addressing. So depending on the question you have, depending on the layer or the level of granularity your data is, you will need a different architecture. Every question needs a different architecture. Now, obviously, you're not going to build 15 different data platforms. One data platform has to address all these things, right? The second is the variety of analysis needs, right? Variety in this case is represented by decision velocity, right? So are you looking to do ad hoc research and discovery? Is that the analysis you're looking to do? Or are you looking to do operational insights and monitoring, right? So a great example is, in the retail world, knowing what to stock your shelf with when you're trying to build out a new store, that is a decision that could take days. But if your product runs out of stock, you need to replenish inventory right away, within minutes. So again, one decision could take days. Another decision needs to happen within minutes. So again, your architecture should be such that it accommodates both. So there's the volume of use cases, there's the variety of use cases, and finally, there's a velocity of use cases, which is, again, represented by all these externalities: political turmoil, regulation, the price of oil, and all those things that you have no control of. And again, I talked about the GDPR example, which is absolutely perfect for this, right? So there's the 3 V's of analytics, and these 3 V's influence the Tableau platform, all the investments we've made over the years and that we're continuing to make. They influence also how Tableau integrates with different cloud platforms. But today, we're going to focus on how it influences your data platform, right? So with that, I'm going to transition to Robin.
Side, how the data platform implements these architectures and on the cloud are going to be largely transparent to you as Tableau users and Tableau admins. But from the analytics side are driving a lot of the principles, as Vaidi said, that impact what the other parts of the platform look like and how they behave. And so just to go over, if you start looking at it from the volume, velocity, and variety of analytics, not just data, you start to see how you need to support multiple applications, multiple roles. And I could do hundreds of applications today that are analytic applications. And each one of you is implementing one or more of those applications, and you're supporting one or more, probably many use cases, many types of users, from business users to data analysts across the whole organization, including IT, including yourselves as administrators, because when you're implementing your analytics and data and cloud platform at scale, your requirements are important to all of the platform, including the analytics platform, including Tableau. And obviously, we've talked about the multiple types of data. all the time. That is the variety of the data, and that's only increasing. And one of the things that is one of the really strong points of Tableau is the ability to combine these multiple types in different ways for the different use cases and the different user roles, the different types of applications. But the data is only getting more and more variable in different types in terms of how structured it is, how you might have unstructured data coming into the system, if you like, if you think of this as a one big pipeline, which is very much how I think of this, the combination of all the platforms, the data platform with the analytics platform. Increasingly, the type of data can drive and support many different types of applications. So we all know about time data and dates and things like that, how Tableau is very powerful in dealing with dates, but also a good example of another very rich type of data that needs to be combined in your applications or analytic applications, or things like spatial data, geospatial data. And that drives all the way back to the data platform and the cloud platform. Tableau's always been very good at doing mapping, but now we're starting to integrate with the databases that also support the geospatial data type to make applications much more seamless all the way through from the data platform through to the Tableau platform. Now, one of the principles that those of you on the data platform have probably been adhering to for a long time now is to decouple the storage from the to have multiple tiers, sorry, of the storage of the data. Historically, when I say historically, we're only talking a matter of sort of months and short years. When we're talking about big data and large amounts of data, a good approach to managing that huge volume and variety is to have different storage tiers, if you like, for that data. And one way to look at it is to think of it as a sort of cold, warm, hot tiering. But I'm always careful to sort of point out that this is more of a spectrum rather than three big buckets, three categories. And I also want to point out that, find it important to point out that when we say cold as a tier, which might be your data lake, we don't mean bad in an analytics sense. It's not useless to analytics because it's cold. You've got use cases and Tableau use cases, it can be very powerful and valuable that actually use cold data. So you shouldn't think of this tiering as a distance from your analytics use case. Now, quite often you need hot data or very low latency data to be able to do certain types of analyses. But we find that the customers who understand the data, even if it's in this colder tier, or earlier on in its life cycle through the data platform, can have a great Tableau can have a part to play, and Tableau use cases can get great value from that type of data, especially in the discovery, especially in applications where you're trying to figure out what the application is before it's productionalized, before it's an operational analytics flow. And quite often you can access cold data and get value out of it, and then that data can progress as you see what the value is, what the application needs to be as it gets more and more operational or more and more productionalized. You can warm up the data increasingly. So the data moves through the tiers as well. It doesn't always stay in one place. And you will sort of select which tier it moves to. And so the warm tier might be traditionally considered as data warehouses and data stores where you kind of know the data, know the question, but you've got unknown answers. And then you have hot data stores, which I think of as your you might think of as like the query acceleration tools. So if you've been down to the Data Village this week and looked at a lot of our partners, the range of partners that we have, some of them have what we think of as query accelerators or hot data stores or in-memory data stores that might be either built into your core data platform, say if it's a Cloudera or one of the traditional big data platform, Hadoop sort of platforms, they have these tiers in as well. And then there are also third parties, including us, that have storage tiers, if you like, for the right application. All right. So I think of this as much more of a spectrum, and I also think of this much more as something that's improving all the time. So what was warm, hot yesterday might be warm today because there's more newer hot type query engines. And one of the things that's true about this whole space, about this platform, that you're building, is that it is a growing platform. It's something that you have to design in the fact that there are very rapid technological improvements happening all the time. One of the other principles is we need to decouple the storage. We decouple the storage from the compute layer, and that is a pretty much a standard principle today. Even the Hadoop platforms, if they've matured, have come to adopt this approach, because I think it's because of the 3 V's of analytics. It's the variety and the velocity of the use cases and the number of use cases that are coming along that have now been created because analytics is such a core part of your business. By decoupling, it allows you to bring the compute and the data together in a much more dynamic and on-demand way as your as you define your use cases, as you look at new applications for your data. And so, all of the on-premise and cloud platforms are pretty effective at decoupling. And so that's kind of the starting point, if you like, this decoupling the storage from the compute. And the onus, if you like, or the principle that is, the corollary to this is that while this is decoupled, while we obviously decoupling storage from compute, what makes a really good data platform for analytics is that we can bring the storage and compute together in different ways at different rates for different use cases. It's just coming all the way back to the 3 V's. And also, increasingly, that we have the importance of metadata and catalogs. It's more important than ever. Metadata has always been useful in our world, in the data world, in the analytics world. But it's actually, it's more important than ever because you need, and we need to automate a lot of the processes and the understanding of the data so that we can build these analytic applications better. So you may have heard this week about our work in this whole area in leveraging metadata and catalog integration, but that extends all the way back to the data platform, all the way back to even your, if you have a data lake strategy, or you think about data ingestion, where the data comes into your systems or where it gets created in the systems, how the metadata is important, and there can be a lot of it. It's in a small data case, you could end up with more metadata than data, to be able to get valuable, good use of your applications. And we can use that to make it life easier for the end users and of the content creators or developers of these analytic applications. So that's a key principle that you would be, make sure that you have that in your data platform as well as your analytics platform. So, you'll see how we're working to sort of hook those all together. So the thing is that with all of one of the reasons why you want all of this metadata is that it There's all these different types of data, and there's all these different details of data, and there is metadata. I couldn't find a nice diagram of metadata, so that's why the dog chasing its tail is there, because that's kind of what metadata is, data about data. So I couldn't find a good, other good picture, but that's a nice picture of a dog anyway. So just recap. To me, the picture of the 3 V's of analytics helped me understand, what our customers' challenges were when you're coming from the analytics, perspective, looking from the analytics end, from the Tableau end, and both the 3V, the big data principles, the three V's of data, no doubt applies. It's very true, and it's more true than ever. But we've now got this other dimension of what looking at it is the 3 V's of analytics. So there's this huge volume, variety, and velocity of use cases of applications, and these principles apply to both the data platform and the analytics platform, and they apply to the end-to-end, holistic view of the combined platforms. Now, while we're doing that and and applying these principles, one of the challenges is to keep that agile. And so Vaidi is going to show you, look at some very specific customer examples, and we have a lot of them, and we're only showing a very small percentage here today. But you might have heard of the other sessions and other things on Tableau customer success stories. When you look at or look at your big data stack or analytics stack, you will have lots of different components. But when I've looked at them, and there is a pattern that this is how I think of the big box, big block view of the architecture. And that alone, though, we'll go into details. We're going to come back to this picture, but there is a sort of pipeline of a flow of the data from ingestion and raw data, and then you remember we said we separate the compute and the storage, so that's how I'm drawing them. But I also usually think of compute in 2 major big blocks, and that is you're bringing data into a compute platform to prepare it, to wrangle, ETL, to clean it, to check it out, create metadata, and then you're also, restoring it. Maybe you're adding structure to that data and adding metadata which you're storing, and then you've got your typical compute query engines, which include your fast analytic databases, the accelerators, or the low latency query engines that are built right into the core platform if you're coming from a sort of Cloudera, Hadoop, MapR type environment, and then bringing it out into Tableau. Now, when you look at that, it doesn't really speak to, well, how do we keep that agile? And that's one of the newer things that we found by looking and talking to our customers, that one of the ways to keep that architecture or platform agile is to kind of think about it as a supply chain. Now, many of you as customers, your business, you virtually all have a supply chain in your business. You are creating product, whether it's a digital product or a retail product or something concrete. You have a supply chain, and you optimize that supply chain. You take a lot of care to optimize that supply chain and keep it running. It's the same for your data through to your analytic applications. Not only is it a single supply chain, but it's a multi-channel supply chain. And so there are different routes through that platform, but it is a consistent platform, that's the key, but it's the way that the data flows through the platform from ingestion through to sort of insight and impact, as we'll see, it can be thought of as a multi-channel supply chain, which is happening in the real world, in your businesses for virtually all of you. Now, when you combine that with what we're starting to see is a sort of, a DevOps, and most of you aren't developers, but the development teams and the developers of software and applications have come to realize that there is a need, because of the pace of change in the continuous requirements and how dynamic your business is, that you have a continuous integration and continuous delivery perspective. So it's what some people call as a CI/CD. And what they're seeing and applying those learnings and principles to their data platform and their analytics pipeline. And so I'm starting to think of this as, continuous integration, continuous delivery, continuous analytics is what you're building with this big end-to-end pipeline. And that sounds scary, but it's not impossible, because we've learned from our customers that have been very successful with Tableau that, and some of you are actually in the room already, so I'm more or less validating what you're doing, I think. I'm hopefully validating it. When you look at your own stack, you say, yeah, we're doing it, and I'm here to tell you, you're kind of doing it right. But Vaidi is going to talk a little bit about some customer examples, and then I'll give you one example of a single flow through a sort of pipeline.
Thanks, Robin. So I'm not going to share how some of the principles Robin talked about manifest in how customers have architected their data platforms, right? So let's step through a few of these. So this is GoPro. GoPro analyzes, billions of rows of streaming log data. And this diagram, it splits their platform between a data pipeline and a data delivery mechanism. So right off the bat, they have created two separate segments. So it's not one monolith delivering everything. Note also the use of Parquet HDFS for storage and Impala as the query engine. So that is analogous to a storage layer, a compute for prep layer, and a compute for query layer. So the compute for prep is it's actually in the, if I go back, that was all being done in Spark, in the Spark clusters. The compute for query was obviously happening via Impala. And if I bring all of that together, again, it's an agile data pipeline. They have decoupled storage and compute. And they also have some catalog integration if you look at the Hive Beta Store. Now, how much of that is being made available for analysis in Tableau, that I'm not sure of, but it could be. All right, so that's GoPro. Next, we have Pearson. Pearson is an education conglomerate, large customer of Tableau, deployed on AWS. So this is a really nice example of data coming from multiple sources, right? Note how they have a serverless Athena and a server component. So they use Redshift for the most productized, packaged, decision-ready, day-to-day business use cases. And they use Athena for the research and discovery, farm-to-table type use cases that I showed you earlier, right? So two separate services being used for entirely different use cases. And again, they address multiple roles and bring data from multiple sources as part of this. Then we have Airbnb. Airbnb, again, they process a lot of event logs. They use Cloudera, HDFS, and S3 for storage. And note that they have two Hive clusters. There's a gold cluster and there's a silver cluster. The gold cluster is dedicated to prep. So this is responsible for doing all the ETL jobs, the business logic, the stringent SLA type work. So it also creates a lot of summary tables. And the silver cluster is dedicated to analytics and reporting. So there's a couple of things to keep in mind here. Number one, obviously they're having to replicate data from one cluster to the other, so there's that. But the upside is they are free from any interference caused by resource contention. That's one. And then they're building some redundancy into the system, right? And their compute for query layer here is astonishingly, there's no data warehouse. They don't have an Oracle, Teradata, Vertica, Redshift. They don't have any of those. But they're directly querying partitioned Hive tables via Presto. And of course, they have Tableau and a bunch of homegrown tools on top of that, right? So again, multiple sources, multiple tiers. This is a classic example of cold, warm, hot. And they have decoupled storage and compute. This is Netflix. Again, they have a lot of high-velocity streaming data. Notice that they have a fast storage layer, which provides compute for query. And they have Spark clusters acting as a compute for prep layer. AWS S3 provides the storage. They have some metadata integration as well. And they have two separate groups. One, of course, does a lot of the data science work, and they have separate tools for that. And they're provisioning all of this data via Tableau for enterprise self-service analytics. Then we have Expedia. We have Tad Buman here in the audience who actually presented this use case first day of the conference. They use S3 for storage, Redshift as the query engine, and you can see a lot of work going into the preparation pipeline. So again, they've decoupled a lot of the different components, and all that data is being provisioned for analysis via Tableau Online. Right? So each vendor, regardless of whether you're on-prem or in the cloud, each vendor has its own big data stack. And today, we're going to call it a data stack. It's comprehensive. It's super impressive. Amazon likes to say their services address a whole range of use cases. The right tool for the right job world. That's where we are. And these ecosystems continue to evolve, but what's important to realize is whether you're on Amazon or Google or Azure or Cloudera or Hortonworks, I know they merge, but I think they're going to operate as separate entities until early 2019 happens, or MapR, all these architectures could fit into that generalized architecture Robin showed, right? All that changes is what services you put into those buckets, right? So, and these, by the way, these are our adaptations, and we literally took the AWS ecosystem, we took those services and put it into these stacks. So this is what AWS might look like, right? So they have Lambda, which is infrastructure as code. They have Glue. EC2, of course, does a lot of the cloud compute. They have storage layer, and they have a range of services. Again, Redshift, Athena. If you want to query your data warehouse in conjunction with your data in your data lake, you use Spectrum. So again, that's AWS. Azure, very similar. Their equivalent of Redshift is Azure SQL Data Warehouse. Their equivalent of Spectrum is something called Polybase. Their equivalent of S3 is Azure Data Lake Storage, right? This is GCP. We have a significant number of customers on Google as well. I'm not going to go into these services in detail. And this is what Cloudera might look like. Right? Again, the query engines change, the storage layer might change, but the architecture, the patterns are all common. So let's now look at a demonstration of how all these patterns could be realized in the real world. So I'm going to pass it back to Robert.
Okay, so I just want the demo here is really just to sort of give you an example of a very single use case that might fit on this combined data and analytics platform or your platform. So it's an example of a single use case in which, in this case, I'm using AWS as the cloud platform and some very specific AWS services that create an agile pipeline, plus an example of a third-party data warehouse data, cloud database, Snowflake, that you might have seen down on the Data Village. So one of our partners, and sending some data from a raw state, ingesting it through to Tableau. And I wanted to show how this single example kind of fits in into our pattern that we're seeing all of our customers have implemented over time with their platforms and that are very successful with Tableau. And so you can actually fit this flow onto this big block diagram quite well. But again, it's just an example. So you've got the application I want to talk about is an application that actually the data that we're analyzing or sending through to Tableau is one of these data types or data creation that is not ingested from the outside itself. It's an application that analyzes data that's ingested and creates new data or metadata about the data that's ingested. So this is one of the sort of dog chasing its own tail type examples, but it's real in the sense that we're taking data that is sort of unstructured at its creation point and giving it some structure that makes it easy for Tableau users right at the other end of this pipeline to build an analysis and to combine it with other data. So AWS has a service called Macy, which you may or may not have heard of. It was actually comes from an acquisition. And Macy is a service. What it does is it's an internal service in that it looks at data that's coming into your data lake. So if you think about the data that comes in at the beginning of a pipeline, like a transaction data or your customer data that comes from your business processes, right? A sales transaction or a customer file or something that you get from a third party. That data can be of all sorts of, all types of data. And it's going to go through this, the idea is that this data goes through this flow into your analytics applications, eventually landing in dashboards and visuals in Tableau. What Macy does, it looks at that data right as it comes into the data lake, if you like, your ingestion point, and looks for sensitive data. So that's PII data, personal information, or secrets, passwords, anything that could be very dangerous to let through the system to a much broader audience. So it's kind of like a guard process that looks at data coming into your data lake. And when it finds sensitive data and it uses machine learning techniques to look at the data, when it finds sensitive data, it can create an alert. Now, the service itself is pretty standalone. It does have its own visualizations. And it gives, for administrators who are actually responsible for the Macy application itself, it provides some important information when it finds sensitive data. And it's extensible and it's quite powerful. But it can also create an alert, which itself is data, which we can actually pick up using these other services in the pipeline and send through to Tableau, so it becomes a data source, so that we can integrate that with our analytic applications. So the alerts that it creates are things like, okay, I found some personally identified data, maybe social security number or something, in this data that we're ingesting, and I'm alerting you about it. And it can do it right in Macy, but we can also take that alert and send it through this pipeline, which I showed, and through to a data warehouse or an analytic application all the way through. And the way that that's done in the AWS world is using services. It's not all Tableau. It's all, other services that you kind of connect together to create an automated, a very agile flow of data. So if you're, I'm not going to go into too much detail, but for those of you that are more familiar with the AWS platform, it's a combination of CloudWatch, which captures the alert from Macy and then sends it on through a flow to downstream to transform it, because I'm going to show you what that incoming data looks like. Most of you as Tableau consumers or content creators never need to worry about the format of this. This is all done from you, and it's still a black box, but I'm letting you know that this is the sort of thing that happens for you in your data platform with your IT, your data platform team. They are adding value and enriching the data for your analytic use cases. So I'm splitting this data up and sending it down a couple of sort of different paths to do different things. And one of them is a Lambda function, and the other one is a Kinesis stream. So we don't have to go into too much detail about that. But it will find its way to Snowflake, which is a data tool. I'll just log in again. Which is a database, right, that sits on the cloud platform. So it's very much, from the Tableau perspective, we have a named connector to it, like we have a named connector to many other databases, different types of data. But one of the nice things about Snowflake is it's native to the cloud, but it also allows you to transform some data on the way through this pipeline into a form that's very readable by Tableau, and the Tableau data model tools can take advantage of the result of this very easily. I want to give you an example of the data, what it looks like coming in. This is the data that I use to sort of build this pipeline. Is generated by a tool, so this is not real personal data, but it looks like it. It's very kind of realistic. But this is a sort of typical data that might come into a system that you need to be looking for, personally identifiable data, so that you're trapping it and alerting the right people at the right time that this might be a new data source that you hadn't checked before, things like that. So this data has social security numbers in it, and Macy will actually find that. The data that is coming in this case, is textual data, which is very typical of a data lake ingestion layer, where you're taking transactions from legacy systems or operational systems. They quite often come in as text, XML or JSON or binary files, Parquet files, transaction files, and Macy can look at those. And it will alert, because it finds things like social security numbers. That's a trigger for an alert, and it's set up to look for those. Even though this data itself is not that well structured, it's not a relational database, it's not already cleansed, it's dirty data. The file that, even in the example here, is not strictly JSON. It sort of looks like it. And so we bring it through that flow, and it's a flow that becomes automated. So when I set this up, I learned the structure of the data, and I applied some rules to get it into a form in Snowflake that is a more typical relational. So those of you who are more familiar with like data warehousing and dimensional modeling, this is a typical star schema where you've got some facts about the alert, and some extra, reference data, lookup data, dimensions that are very useful. This is the sort of thing that you can point Tableau at directly, especially with the data model, and it will understand that schema out of the box, and then you can start building. But I've automated the pipeline to get the data from the raw data to the relational view ready for Tableau to consume with its data, the data model. And you can do this today with Tableau, but it's going to be really easy because of the metadata and the structure that this sort of pipeline can create with the data model. So I'm kind of getting you prepared, as well as saying you can do this today, and our customers have been doing it for several years. It's going to get even easier with the features that the capabilities that we've been showing you this week. And that's why you need to be prepared. It would be really great if you're ready and working with your data teams to get this, metadata, this pipeline in place. It's going to pay huge dividends in how easily you can do the analysis of this data. So once it's in this form, it becomes a very, typical Tableau use case where you're just, connecting to a data source, whether it's Snowflake or Redshift or Athena or, Impala, Oracle, SQL Server. It's all the same thing at this point. It's a relational, structured source of data, and it becomes something that you can build Tableau visualizations on very easily. Now, the nice thing about this is I didn't touch this since I built the pipeline and it's automated. I didn't actually touch this for a while, so it should be giving me new data without me actually touching it. So if we go to the messy details here, I can actually look and refresh the data, and we should have the latest data. So this just looks like a typical Tableau connection. I think we're a bit short on time. I won't sort of refresh it, but that's where if we do hit it refresh, we might see the sort of different dates and that. So it's been refreshing. So that's the data all the way from the beginning to the end through to Tableau. So that's one flow. The point is that your platform that you and your platform teams are building, your data platform team and your Tableau platform team are building those together to create your analytic platform. And it makes it, with the right approach, it can be very agile and support many, many, many different use cases, different applications. Okay, I think that's good time to hand back to Vaidi to recap.
Yeah. Excellent. Thanks, Robin. Oops, I think we went back all the way, huh? Let's see. Oh, we had all these information in the slides as well, so I'm just going to.
Yeah, I had the.
Oh, you forgot to say about the Tableau prep piece.
Oh, right.
Yeah.
So when I said that you can build sort of typical Tableau applications, it may be that even in this, when you have this very agile pipeline and integrated platform, that so you might have new use cases where the data doesn't exist yet in that platform. And one of the great strengths of Tableau is the ability to join, the data from your analytic, your data platform, with new data that might even be sitting on your desktop in Excel or from some third party that has not yet been integrated into the big platform. And so this is one of the other ways to be agile, is that you can combine that data with a lot of the Tableau tools and the things you know and love about Tableau, being able to join that data and with the Tableau tools. And so you can take data that might be in Excel and adds value to the data that's come through the pipeline, and use the Tableau prep and Tableau desktop and Tableau server and to join that data even at the late stage to create a new use case as you learn more, or as you drive new applications that maybe the data didn't exist. So it keeps you agile on the Tableau end.
Great. All right, so I'm going to go ahead and just recap some of these takeaways. So, I mean, these are all, they aren't meant to be rules, just guidelines to think about as you architect your data platform. So first is, you got to be specific in the short term and flexible in the long term. What does that mean? So it means that while you are addressing specific measurable business goals to deliver value to the business, you have to architect in a way that can accommodate newer use cases that you haven't thought about going well beyond an immediate time horizon, right? So that's the first thing. Second is architectures that have intelligent defaults are always a good thing. An architecture with an intelligent default is exactly what Robin talked about. Something that can analyze JSON, right? Something that will let you take different decisions. Not something that works only on relational or works only on a certain type of data or serves a certain type of user, right? So architectures that should be agile, flexible in the longer term, and that have intelligent defaults, very important. Second is this is more an analytics culture thing, but very important as you go about architecting a data platform to involve the business, have a representative from each function that you're serving participate in the process of architecting. So even if, regardless of whether you're in IT or the business, I've really seen hub and spoke models work very well. So if I'm I'm running the project and I'm sitting in IT, it's very important to have dotted lines to each one of my business stakeholders and have them actually participate in the making of it and not just be involved as a stakeholder and just be answering questions. They got to be accountable and they got to do a lot of the work as well, right? Embrace continuous improvement. Again, this is going back to a DevOps mindset, right? You have to promote ad hoc analyses. So provide your business users and everyone within your company the ability to not just serve the KPI type repeatable analyses, but also conduct the farm to table type ad hoc research and discovery type analyses. And if you're doing some ad hoc discovery and you find something that might have some long-term usefulness, automate, right? Cannot overstate the importance of automation. And automation is not just serving up extracts into creating data sources in an automated way. It also implies automating the pipeline, automating all the different feeds. So the Macy alert example is a great example, of how you can automate that pipeline. Then you have to consider the breadth and depth of use cases. This sort of alludes to what I talked about earlier, but data is multi-channel. You have to think of it as a supply chain. There's different paths that are available for data to arrive to a state before it is analysis ready. So you have to think about that. It is multi-source and it's multi-layer, right? There's different layers of storage, different layers of compute, and again, depending on how often, how frequently your data is analyzed, and of course all the 3 V's, you have to factor those things into the architecture. And don't, of course, always wait for data to be in the lake. There's many customers who haven't even thought about a data lake. They're still working off of spreadsheets. They still have that relational data source. But as a data lake gets created, analysis should continue to happen. You should continue to think of these as agile projects where you're, conducting analyses piecemeal, delivering a prototype, getting the business to react to it, which boosts the business case for the next project. Right? And finally, always learn from the community. So there's a Tableau community, there's an open source community. If you're in the Hadoop world, there's so much innovation happening in the Apache open source system. There's newer execution engines coming up every day, newer ways to optimize. our customers are usually always ahead of us, so they'll find things that inform our product roadmap. So I think that's cannot overstate how important that is. And a lot of these best practices that we covered here, including many others that we did not cover, have all been summarized in this white paper that we just launched last week. Definitely go ahead and check that out. But I think that's all we have for now, and we can take some questions.
So for automation, with like, you're staying agile, you're adding all these compute tools, all these ETL tools, analytics tools that are restoring data, and each of these tools have different scheduling systems and automation systems. What's your opinion on kind of the tools becoming available for workflow automation? That decentralize that, because you have all of these tools.
Right. So depending where you're at on, in your kind of platform journey, that's something that is really an active area where people are starting to see that you do have this big end-to-end platform, pipeline. And so there are tools that are actually being created to help manage bigger chunks of the end-to-end platform. I mean, I take a bit of a pragmatic view, and it's always changing, and they'll never get to one, size, one tool fits all or one size fits all. But you will, as your journey progresses, probably sort of aggregate those and find tools that can cover more and more of it. And it's starting with that mindset and being on the lookout for those tools that keep that ability to to automate and schedule and trigger, while being pragmatic about it, in that there might be still, today in your environment, a few, tools. You'll always be minimizing, but you'll probably never, might never reach one. So I think that's always be minimizing is the goal, I think, here. So I understand that there are tools and capabilities coming out all the time. But if you can have more and more of the capability in the different tools. A lot of legacy sort of scheduling tools you can bring to bear, and they'll add value to the pipeline without being, covering the whole end-to-end thing. I think that's what we've learned that from our customers. They found ways to keep it agile.
Like something like Airflow, would that be a good?
Yeah, exactly. Yes. Yeah. Yeah, so there's open source, there's third-party tools, and one of the nice things about an Airflow, I think, would be because they are recognizing and have a lot of experience in knowing that they have these challenges end to end, and that sort of tool set and capability is designed for that, and so you'll find that from the open source community and the proprietary vendors.
What does it mean by catalog integration?
Metadata integration, but also catalog integration.
Okay, all right. So I had a Tableau doctor appointment yesterday that was a good example of why you need a catalog. And the catalog type and metadata type information has two major kind of benefits. One is like looking for like impact analysis and change control. So knowing that if you change something very early on upstream in your pipeline, how it might impact the rest of the pipeline. Yep. Metadata and catalog is becoming more and more critical for that across the whole breadth of the pipeline. The other area where metadata and catalog is actually really useful is helping people find the right data and the right visualizations. And that's a huge benefit as we scale up. That's why I said, Vaidi or I both said right at the beginning, when you look at this through the lens of the 3 V's of analytics, about the increasing volume and variety and velocity of your use cases, the need for metadata and catalog tools becomes more and more important, because you have to help your users find the right information to use in their analyses and the right visualizations and the right data.
One thing I'll add to that is when you give users more visibility into how something, a data element originated. It adds trust, right? It abstracts. I mean, even with many of our customers, the analyst may not know right away whether to trust a data source or not. I mean, today, even within Tableau, we have certified data sources and all that, but not every data source makes it to Tableau server, makes it a data server. So it's just promotes more use, gives the path, the lineage, and it helps the user understand it while abstracting away all the complexity of.
Yeah, I think of with the work that we're doing on catalog and metadata and recommendations, that's all foundational to help users find, go faster in getting from the raw data to the insight. The foundational kind of tools or capabilities that allow us to make the whole pipeline faster.
And you need a specific tool to kind of browse and store that data, or how is that?
Well, the tools themselves have both browsing capabilities. They usually have a GUI. You'll find
Searchable UI. So
they're
it's
searchable. So there's visual components, but they also usually have in the background a sort of API that allow other tools to sort of integrate and speak to each other. That's really important when you think about it end to end. It's not just the fact that we have a catalog. We know when we're building our catalog service, it's going to catalog everything that it knows about Tableau, but we know that it needs to bring in information from upstream in the pipeline.
there's a few on the trade show floor. So Unify, check them out. Alation, Informatica has Enterprise Data Catalog, which actually, I mean, all of these integrate with Tableau. So, yeah. Sorry, question.
Do you want to do the micro?
You have this kind of platform or system, just like coming from a geospatial background. When we're doing the catalog, we have our catalog, so you have all the metadata, and then you can have thumbnails for all the visualization. So I don't know if you will. Sorry. Yeah, I was just trying to see if you have this kind of cataloging system, because I can see the importance once you have the data lake, and you have to describe all the data sets, from the injection process. But then in the same time, you're talking about from that, Tableau, you have this kind of data visualization, all the metadata for all these reports. So I'm trying to see do you have any kind of a system to put everything from the data sources to data,
Yeah, well, that's also part of what our new catalog capability is building. So that that we're showing that down in Tableau Labs. So it's both a combination of what the partners and other tools can do and what we're doing with the catalog. Today, customers are finding ways to do it with Tableau by querying our repository, Tableau repository, things like that. But the catalog makes it so it's going to make it so much more easier.
So I'm sorry.
With its own.
It looks like we're being
All right,
pushed out of the room, but we can take questions outside, so no problem.
Thank you. Thank you all for coming and staying for the last session of the day, and I hope you all have a good trip back.
We can take
home.
more
Thank you.
questions. If not, safe flight, everyone.